Hi everyone. So let's discuss factors and multiples. One of the important and basic concepts that we all should know for the exam. Most of you would have come across factor or divisor. Now what is a factor or divisor? Let's say an integer, for an integer n, a factor means you divide that number by a factor. It will be completely divisible, or you will get an integer, right? For example, you can see that 4 is a divisor of 12. Why? Because 4, you divide 12 by 4, you get an integer. It's completely divisible. Okay. So factors basic definition is that the factor must divide the given number. Okay. Only then that number can be a divisor. For example, another divisors or all divisors of 12 are 1. 1 can divide any number divided by 1 will give us the number itself, which is an integer, right? 2 is a factor of 12, 3, 4, 6 and 12. Okay, so these are called the positive factors or positive divisors. Now the same way, as per the definition, if you divide a factor, right, you should get an integer of that number. So 12 upon 2 is an integer. 12 upon negative 2, which is negative 6, is also an integer. So as many positive factors are there for a number, that many negatives will also be there. So that's what it is mentioned here, that 1 and negative 1 are the divisors of 12, right? Similarly, 2 and negative 2, negative 1, negative 2, negative 3, so on, they will be the negative divisors of 12. Okay, so the definition is simple. If a number, if it, let's say there's a number and a divisor has to completely divide that number, leaving no remainders. We'll see that in later stages. Okay, remainder has to be 0 basically, or is completely divisible. A divisor completely divides the number. Now, what is a multiple? Multiples are quite straightforward. They are basically the tables, right? So multiples of 4 is 4, 8, 12, 0. So you multiply 4 with any number. So all of these are multiples of 4, right? So the same way, 4 into negative 1, 4 into negative 2, negative 3, so on and so forth, right? Multiples. So for any number, there will be infinite multiples. So that's why this dot 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 is given on either side, right? There are always infinite multiples of any number. Okay, 0 is a multiple of all integers, isn't it? So any number you multiply by 0, you get 0, right? Irrespective of this number n. So that's why 0 is multiple of all numbers. The same way we have seen 1 is divisor of all numbers. Any number you divide by 1, you get the same number, right? You get an integer basically. So you can remember this, 1 is a universal divisor, 0 is a universal multiple, right? Okay, now these three statements are important here, assuming that x and y are integers. If x is a factor of y, for example, if 2 is a divisor or a factor of 12, how will we write? Okay, there's a mistake. You can change this. So y upon x has to be an integer, which is 12 upon 2 is an integer, right? So factor will always come in the denominator. Okay. If x is a factor of y, then we can say that y upon x is an integer. Now integer you can represent by I or q or whatever you are comfortable with, z. Now if x is a multiple of y, so we have seen, take any multiple of 4. For example, 16 is a multiple of 4. Okay. So that means 16 upon 4 is an integer. So x multiple will always come on the numerator and factor will always come on the denominator, okay, of any number basically. So all of these are very important. You'll need to remember this. If x is divisible by y, okay, of course 16 is divisible by 4, okay, same way. So x upon y is an integer. So the third statement we have come across a lot of times in our school days, x is divisible by y. That means x upon y is an integer always. So these three statements are important. You need to kind of by heart this. Okay, we'll solve some questions. What is the value of smallest positive integer? Okay, what is positive integer? We have seen positive integers are this. Okay, what is the smallest positive integer for which 6 power n is a multiple of 24? This is where the statements come very handy. X is a multiple of y. That means x upon y is an integer. So over here, 6 power n divided by 24 has to be an integer. Okay. So the best way to solve this is to substitute, right? So when n is 1, let's say 6 power 1 upon 24. Is this an integer? The answer is absolutely not. For 2, 6 square upon 24. Now what is 6 square is 6 into 6 upon 24. We know that 36 upon 24 is not an integer. The next is 6 cube upon 24. 6 into 6 into 6 upon 24. Let's try to solve. 6 ones are and 6 fours are goes in the 6 table. So they two go in 2 table and one more. So what gives us is 9, and this is definitely an integer. Now if 3 satisfies, 4 will also satisfy, definitely, and 5 will also satisfy. But they're asking for the smallest positive integer. We don't want all integers, we have the smallest. So the smallest will be 3. And one last. Answer the following with yes, no, or maybe. If 40 is a factor of x, let's say what is given is x upon 40 is an integer, right? Question is x upon 10 an integer or not? So let me take x upon 40 as capital I. Okay, integers I am assuming as I or z for convenience. So what I'll get is x is 40 into I. Now what I need to check is x upon 10 an integer or not. Definitely if x is 40i, this gets cancelled 4 times, 4i. Where I is an integer, so 4i is also an integer for sure. So the answer is yes for this. Okay. If a is divisible by 10, so this is a statement that means a upon 10 is an integer for sure, or a is 10 into I. Question is 4a upon 20 an integer or not? So let us substitute. A is 10 into I upon 20. So this cancels twice and this cancels twice. What we get is 2i. Yes, we are getting an integer. So that means 4a upon 20 is an integer for sure. So 4a is divisible by 20. So the answer is yes for this. Same. If a is divisible by 20 and 30, okay, so that means a upon 20 is an integer and a upon 30 is also an integer, let's say. Okay, then a is divisible by, is a divisible by 42? Okay, what we understand is that a is a multiple of, so first we'll need to take the common values, right, of this. So as per this statement, what values a will take? multiples of 20, right? So 20, 40, 60, 80, 100, 120, and so on. And A can be is equal to 30Z, which is multiples of 30, 60, 90, 120, and so on. Because A has to divide both of this, so A can take only the common values. So what are those common values? The first value I can see is 60. Then 120. So A can take 60, 120 in the gaps of 60, so 180, so on. Now, is A divisible by 42? No. 60 is not divisible, right? 120 is not divisible. 180 is not divisible. But if we go ahead, we'll get somewhere. If we go ahead, next is 240, 300, 360, and 420, and so on, right? So there is a value which is A can take 420 also. So is 420 divisible by 42? Answer is yes. So is A divisible by 42? The answer is no and yes. So that's why we will say this is maybe. Maybe it's divisible, maybe it's not. We are not sure about it. Okay, so this is how questions on factors and multiples will be tested. And I hope the concept is clear. So I'll see you in the next video. Thank you.